video, we're going to discuss how to count functions with certain properties. We've seen that many counting questions can be rephrased as questions about counting functions with certain properties. This is reasonable since many counting questions can be thought of as counting the number of ways to assign elements from one set to elements of another set. All right, let's do an example together. You decide to give away your video game collection so as to better spend your time studying advanced mathematics. How many ways can you do this provided, let's just start with one for now, you want to distribute your 3 different PS4 games among 5 friends so that no friend gets more than one game. Okay, so for this first part, we must use the 3 games. Let's call them 1, 2, and 3. And we're assigning these 3 games to 5 friends, which we'll label as A, B, C, D, and E. Okay, so how many functions are there with domain 1, 2, 3 and codomain A, B, C, D, and E? Well, the answer is 5 cubed, which is 125. Why? Well, since we can assign any of 5 elements to be the image of 1, we have 5 choices here. We have 5 choices for 2, and we have 5 choices for 3. But this is not the correct answer to our counting problem because one of these functions is f equals, for 1, 2, and 3, we're sending 1 to A, 2 to A, and 3 to A. That function is counted in these 125 different functions. So one friend can get more than one game. What we really need to do is count injective functions so that no 2 games go to the same person. So in order to do that, this gives P53, which instead of 125, this is 60. So this is the answer to our counting question. All right, let's do the second part. You want to distribute your 8 different 3DS games among 5 friends. Again, we need to use the 8 games as the domain and 5 friends as the codomain. The nice thing about using functions is it's always going to be the same setup. So here we have 1, 2, 3, 4, 5, 6, 7, 8. All right, so we are counting all functions. So the number of ways to distribute the games is, in this case, 5 to the 8th power. 1 can go to A, B, C, D, or E. There's 5 choices for 1, 5 choices for 2, 5 choices for 3, and so on, which is 5 to the 8th total functions. And so there are no restrictions about how these 8 games are given out to these 5 friends. And so the answer is 5 to the 8th power. All right, for the third part, you want to distribute your 8 different SNES games among 5 friends so that each friend gets at least 1 game. This question is harder. Use the games as the domain and friends as the codomain. The reverse would technically not give a function. To ensure that every friend gets at least 1 game means that every element of the codomain is in the range. In other words, we're looking for surjective functions. So again, we have 8 games here and 5 friends. And we are looking for surjective functions. So how do we count those? Well, surjective functions are not as easily counted, unless the size of the domain is smaller than the codomain, in which case there are none. The idea is to count the functions which are not surjective and then subtract that from the total number of functions. This works very well when the codomain has 2 elements in it. Let's do that example. And then this one we can save for much later on. So let me clear everything and then set up a much easier question here. How many functions from 1, 2, 3, 4, 5 to A, B are surjective? Now again, the level of difficulty of this question really depends on the size of the codomain. So instead of starting with 5 friends, we're going to start with 2 friends to make this a lot easier. There are 2 to the 5th functions altogether here. So to count the number of surjective functions, we have to subtract all the functions that are not surjective. And it turns out that counting functions that are not surjective is really easy using the principle of inclusion and exclusion. Okay, so there are 2 choices, again, for each, for where to send each element here, which is why it's 2 to the 5th. So now, of these, the functions which are not surjective must exclude 1 or more elements of the codomain from the range. So first, let's consider functions for which A is not in the range. Well, this can only happen one way. Everything gets sent to B. Alternatively, we could exclude B from the range, and then everything gets sent to A. So there's only one function like this. These are the only ways in which a function could not be surjective. No function excludes both A and B from the range because then you wouldn't really have a range. So in this case, it's 2 to the 5th minus 2. And namely, again, these functions are f of x equals A and f of x equals B. This function rule makes it so that B is never an output, and this function rule makes it so that A is never an output. These are the only two functions that are not surjective. And so because of that, we subtract all of the functions that are not surjective, which is 2 to the 5th minus 2 surjective functions. In the next video, we'll discuss how to count surjective functions with larger codomains using the principle of inclusion-exclusion. And that one's going to be a little bit trickier, but then we'll see how to build up to distributing 8 games to 5 friends so that the functions are surjective. Anyways, thanks everyone, and I'll see you in the next lecture.